morning. Let's start with the today concept. Today I am going to discuss what is HDFS. What are the features or characteristics of HDFS? These 2 points we are going to discuss in today's session. Then we are going to move ahead with the HDFS storage systems or any other system. Okay. So what do you mean by HDFS? HDFS basically stands for Hadoop Distributed System. Distributed file system. So, or we can say HDFS is a distributed system which is designed to store huge files in a commodity hardware, not on a cluster environment. Basically, HDFS stands for the Hadoop Distributed File System, and HDFS is a distributed file system which is basically designed to store huge files, a commodity hardware, which is basically run on a cluster environment. These three things is very important. Huge file means the number of files are not huge. The size of file is huge. By a huge file, I mean that the number of files are not huge, but the size of files are huge. Okay. Basically, what happened? We will consider. Let's show you in a diagram. Trying to explain you. That's supposed to be a Windows system where basically files are stored in some storage unit. Basically, it is stored in the form of block. But what is the size of the block? Okay. So each block in a Windows file system is up to 4 KB. Okay. This is the file structure of a Windows operating system is having. Okay. In a Windows environment, the basically each and every cell, this cell, this cell, each and every cell, okay, of 4 KB. What happened? It is a 4 KB, it is a very small file, right? But in HDFS file system, the size are beyond that. That means it is the size of the file is generally in megabyte bytes, gigabytes, bytes, GB, or terabyte, GB, and more than that, and so on. Okay. The HDFS is able to store huge file size or huge files, or we can say large file. Not number of files will be more. Speaking, the file size is huge or the file size is very large. That means we'll consider the window environment. In the window environment, each and every file stored in form of blocks, it is up to some 4 KB only. Okay. It is maintained some up to some MB, but each and every file size that is stored in a particular block, and each and every block is up to some MB. You can design up to MB, gigabyte, gigabyte, terabyte kind of file size it is going to store. It will store. Okay. Then commodity hardware. What do you mean by commodity hardware? Commodity hardware, you mean that commodity hardware are nothing but the cheap hardware, cheap or low cost hardware. A personal laptop, 1 TB. Okay. What is the cost of that 1 TB laptop? Almost 60,000 or 70K or 80K. But in traditional system, the hardware that is managed in the any data center, because in earlier, before Hadoop came into market, almost all the organization, they have their own data center where they are going to manage high-end hardware. Cost are very high. That means expensive hardware. However, we are getting a 1 TB hardware, 1 TB hard disk, store our data within 60K or 70K or 80K. It is not a huge amount. Okay. whenever it is, because it's a low cost hardware only, not a high end hardware. But these hardware are getting failed at any point of time, that is not reliable. Okay, but in earlier company are using high-end hardware, that is to store the 1 TB of data. They are to purchase that, to invest. They are investing almost 50 lakhs, 60 lakhs, 70 lakhs kind of things, because those hardware are so much expensive, that because they are stable, they are reliable. So keeping an eye on this particular issue, investing so much money, particular, if you want to store only 5 GB also, the cost of high end hardware will be almost 10 to 15 lakhs. Okay, it is very difficult to bear the expense at one hand. Another one, this hardware also, if it is at any point of time it gets failed, then also it is very difficult to manage. Come out from such kind of issue, organization started using the HDFS file system. This HDFS file system connected to more than one machine. Each and every machines are nothing but the commodity hardware. Okay, let me take the another diagram. Okay, this is our, let's say, master node. This is our slave node 1 run in Hyderabad location. This is another slave node 2 run in Bangalore location. Bangalore location. Let's say this is one another node 3 run on Delhi location. Let's say another node which S4 run on Mumbai location. Let's say this is one server S5 on Pune. Okay. So whereas this master node only, okay, master node, the master node only, the master node only configured with the high-end configuration. That means the cost of the hardware is very high in case of master node. But these are all the commodity hardware. Commodity hardware means it is the normal hardware that you are using to store the data. It's very, the cost of this hardware are very low. Means the normal computer that you are using, that is it is the same kind of things only. That means HDFS is designed to such a way that we can able to store our data not only in a distributed environment. That means we can distribute the data among multiple nodes and store them and do our processing in a parallel manner. But also they are eligible to store in a commodity hardware. Commodity hardware means low cost. Cost of the expense to store the data is very low. Because that's why there are chances of getting failed. This node is very high as compared to master node. Because master node are the high-end configuration hardware they are using. That's why these hardwares are reliable. There is least chance of getting failed. In case of master node, there is least chance to get failed. So these are the different data nodes. So we are also, that's why I'm telling we are telling that HDFS, a distributed file system, basically store huge amount of data, not only a single machine but multiple machine, whereas each and every machines are of commodity hardware. They are connected with some common and dedicated network known as the cluster. Means these nodes are designed in such a way that used to store data not only huge in amount, and the size of the files are not only huge, it is a large size of file, but also they are going to process in a parallel manner, and also they are able to run on a commodity hardware, a clustered environment. Okay, this is the importance of DFS. So let's say what is HDFS, you understand, right? And characteristics or FEAT features. What are the different features of HDFS? First and foremost features is designed to run on a commodity hardware. Okay. Commodity hardware means very cheap hardware. The cost of investment is very low. Okay. I have told you, I have installed the Hadoop. I can run the Hadoop in my own system. What is the cost of this particular laptop? Only 70,000 or 60,000. Such a machine is able to run the hardware, run the Hadoop cluster. Then my investment of the business is very low. I can pull to not a huge amount and reduce a huge cost, right? Investment usually very low and easily run the business. Designed to store huge files, but not for small files. Okay. Earlier diagram I have shown you, right? In a window environment, basically we are storing a 4 KB of file. Okay, 4 KB of file. But Hadoop is distributing minimum 64 MB, 128 MB or TB kind of files, or more than that also. So what will happen? Whenever you are going to store in each and every file, there is a meta information which automatically maintained by the master node. The number of files will be split into small chunk. Each and every chunk, we need to maintain the meta information. Okay. We will divide the file. Let's say divide the files here, small pieces. Then to store each and every piece, because HDFS is maintaining some blocks, so each and every block will be getting stored here. This block is getting stored here. Another block is stored here, and likewise each and every block again going to replicate into multiple nodes. This block also, suppose by default, suppose 3 times. 3 different slave machine is going to store. So what happens is it is going to maintain the 3 different address copy in the master node. The master node is only responsible for the storing the meta information, where the actual data will be getting stored in your data node only. And that's why to maintain huge amount of meta information is very costly affair. Okay, it is a very costly affair to maintain such huge amount of meta information. Okay, that's why the size of the block is, instead of going for the 4 KB, 5 KB, 10 KB, Hadoop by default giving you, are using the Hadoop 1.x, the by default file size is, block size will be 64 MB. Going for the Hadoop 2.x and 3.x, it is going to maintain 128 MB. Okay. Getting this point? Yeah. Then next. Design be fault tolerant. What do you mean by this? Design to be fault tolerant means as we are going to, whenever we are getting one file, okay, whenever a file request is being sent to the Hadoop cluster, the file request always received as a name node only or master node. Okay, master node is only going to receive that particular file node request, and it is the responsibility of the master node to divide that particular file into number of blocks and accommodate or store into available nodes. Okay, based on the configuration, default configuration, it is going to store that particular block. That's why if one block we are going to lost, suppose this data node is getting down, the Hyderabad machine is getting down, then we can recover the same block from another or same data set from another node. So likewise, the fault tolerant means at the time of system failure, if the backup copy is available, we can take the help of that backup copy and will open our processing without any failure. In layman terminology, suppose you are using the generator. Okay. Suppose generator or any inverter. Then what happens? Whenever the power is gone, immediately within next few seconds, the inverter will automatically start it. Inverter will going to start and gives the power backup. Right. Likewise, that is called fault tolerant in our HDFS file system. Any point of time, if one node is gets fail, then another node going to start, so that whatever the processing will be done by the same backup copy will be available in another node, and that particular copy will going to start the processing, so that we can address the fault tolerant situation. Fault tolerant means tolerant to any kind of failure. Okay. So HDFS is designed to be fault tolerant. Designed to be designed for high throughput. Suppose basically what happens, whenever you are processing data set in an Oracle database or any other database, what happens? The number of records you are going to process up to some lakhs or some millions kind of things. But here, going to pass some million of records. Throughput means simply throughput. The meaning of throughput means the number of rows process rows can process within a given period of time. So high throughput means we can, as compared to other technology, Hadoop is capable to process huge number of records. Okay. That is called high throughput. Designed to low latency. Low latency means the speed. It or amount of time can to around time takes to complete the processing. Okay. Latency means suppose you have given a task to complete within 40 minutes, but you have taken almost 45 minutes. Then it is comes under low latency or high latency. It is definitely comes under high latency. Low latency means within, suppose you have same task performed by another guy within 10 minutes. Which one is better? Same task completed by A within 10 minutes is better, or it is completed by guy within 45 minutes is better. Definitely required with a minimal time period, if we are able to finish our task, that will be good for us, right? Because at the same time, no doubt, at one side we are using the commodity hardware, which is basically cheap cost, low cost hardware. But another way, we need to also keep eye on the amount of time we need to invest to process a particular data set. Okay. So the time also, both money and time, both are important. Keeping an eye on this kind of issue or this kind of things, HDFS has been designed. It is not only designed to run on a commodity hardware, store the huge number of files, huge or large file size, but also that is also good to provide the good backup mechanism so that it will be fault tolerant. Means the replication factor of the is will be good enough so that we can avoid any unforeseen any kind of system failure or hardware failure. High throughput. We need such a kind of mechanism or such a kind of tools or technology that can allow us to process huge number of rows and that can able to scan within fraction of second millions and millions of records and process that. Low latency. What do you mean by low latency? Low latency means the speed or the amount of time it will going to take should be very less. That the low latency, the lower the latency, that will be good for the performance for the HDFS. Okay. These are the important concept. Okay. Then one second. Yeah. It is one more thing. HDFS is not designed for the small files. What is the issue? Because I have told you, while going to store, you will divide one file. Suppose I have a 100 MB file. Will divide into number of KB file. Then it will definitely generate more number of files. More number of files means required to more number of metadata will be generated, and more metadata will be generated means we need to manage more memory. We require more memory space in master node. So to avoid that's why we require the large file size. Another important point is design. It is very important. Design to move the computation logic near to the data. Any technology that you are speaking about, okay? Any technology you are speaking about, Oracle database, any database or any Java, everything. What happened basically? They are going to move the in our Oracle database whenever we run a store procedure. The store procedure will not go to the data. The data is moving to the store procedure, process it. But in our Hadoop, what happened? File will be stored in a particular place. Okay. Suppose one drive or B drive or C drive or some directory it is going to store. But for logic, we need to. It is our responsibility to push the logic to the file that is exist. Which one is costlier? Moving the data to the logic is costlier, or moving the logic near to the data is costlier? Any answer? No doubt, moving the data is a costlier affair because
This one, can you please tell again that one, that point? Did not get that one.
suppose in our traditional technology, what happened? Always data set is there. Okay. Let's say I have a data set. To process this data set, I have some business. I have implemented some business logic. Okay. Logic. Traditional system, what happened? This logic, we are moving the data set to the business logic so that we can process our data, right? In a traditional system, what happened? Basically, we are moving the data set to the nearest to the logic and process the data. Because whenever we are going to write a stored procedure in Oracle, what happened? Data set, we are bringing the data set to the logic. Then only it is going to process. So what happened in this case? It will take much time. Okay. But in case of Hadoop, what happened? We are not going to bring the data to the nearest to the logic. Instead, we are bringing the logic to the data. Data it is stored in some directory. Data set means it is the file will be stored in a directory. We are moving our logic to this particular file and implement our logic on top of that particular data and get the required result set. We can moving the logic means whether you are writing some MapReduce program or any peak